Hello everyone. Today I am going to explain you how to solve interfacing related problems in microprocessor. So you have been given a question, that is design 8086 based system with the following conditions. So first is 8086 working at 8 MHz in minimum mode. Now as we are given this, we can solve first question as 8086 working in minimum mode. Okay, so we have given working frequency, that is 8 megahertz. Now from this we have to derive a crystal frequency. So crystal frequency is nothing but 3 times of working frequency. So 3 into 8 megahertz will give me 24 megahertz. So this is my crystal frequency. Then I have second condition, that is 32 KB EPROM using 16 KB chips. So I have given available is 16 KB and required is, so the required is 32 KB. Okay, now we have to find the number of chips required. Number of chips required will be equal to required upon available, which is nothing but 32 KB by 16 KB, which will give me 2. So the number of chips required is 2. Now we have to find number of sets. So number of sets formula is number of chips required divide by 2. Now this 2 is for even bank and odd bank, as there are two addresses, two banks. One is even bank in 8086, one is even bank and odd bank, so we will always divide it by 2. So number of chips required was 2, will be divided by 2, we will get 1. So the number of sets required is 1. Okay, now we have to find the set size. So set size will be equal to available into 2. Now this 2 is similar for even bank and odd bank, as there are two banks, so 2. Always multiply the available into 2. So available is 16 KB into 2, which will give me 32 KB. 32 KB can be represented as 2 raised to 5 into 2 raised to 10 for KB. For KB 2 raised to 10 and 32 2 raised to 5, which will give me 2 raised to 15. Now as we got 2 raised to 15, we have to write 15 times 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And the remaining will be zeros. As the physical address is of 20 bit, so it will be divided into 5 fours. That is, we have to write 15 times 1, and the remaining on the left side, which are left, will be zeros. So when we write it, it will be 0. This will be 7. Okay. This will be 7. This will be F. This will be F. And this will be F. Okay. So this we have got is nothing but called as displacement or distance. Now this distance, now we have to find the set size. Okay, so first we take starting address, as there is no other day address used anywhere else, so we'll start our starting address with 0000h. Now in order to find the ending address, we have to add this displacement with the start address. So 0000 plus 07 FFFH will give me 07 FFFH. So this I got as the ending address of the set. So I have only one set here. So the start address will be 00000H and ending address will be 07FFFH. Now we have to make a table. Okay, so table consists of memory, then bank, address, then all the bits of the address line A19 to A16, A15, 14, 13, 12, 11, B11, then A10 to. So this is the table. 4 bits I have kept in one column. Now I have to write the hexadecimal address. Now starting with memory, I have EPROM, which is of 32 KB, and there is only one set. The bank is even bank and odd bank. So even bank also have some starting address and ending address. Similarly, odd bank have start address and end address. Okay, now as we are starting from, now as this is even bank, okay, so I'm gonna write the hex address of this. Now as I'm starting from 000, so I will write the start address as 000. End address will be 07FFEH. Even as it is even bank, so the end address will also be even. If I would have taken 07FFFH, it is F is nothing but 15 minus now I want 14, so E. Okay, now for odd bank, similarly I will do the same. I will add 1 here, 00001H, as I'm starting from an odd location, and I will add as 07FFFH. Now I will write the binary equivalent. Now as it is 000, I will write 4 times 0. Okay, then 07FFEH. So 07FFEH. Then 1. So 00000000000. Then 07FFFH. 07FFE. No, F no. F. So I have done doing this. I will now start with the decoder. So now we have to see from the left hand side of the address bits which bits are not changing. So these bits are constant, they are not changing. Okay, so I will take these addresses in decoder, that is A15 to A19. So I will draw a decoder. Okay, decoder A15, 16, 17, 18 and 19. As there are 1, 2, 3, 4, 5 inputs, I will 5 is to 32. Now from where this 32 came, this is nothing but 2 is to 5, which will be 32. So now as here A15 to A19, that all bits are 0, so the output will be Y0 bar, and this output will be going to CS bar of EEPROM. Okay, now the decoder has been done. Now we'll make the actual interfacing diagram. So first of all, you have to make 8086 in minimum mode ka diagram. So there will be your clock generator. Okay, so there will be your crystal frequency, so you have to draw that, and here you have to write 24 megahertz, which we obtained from there. So there will be 3 input signals here: clock, ready and reset. Now as we have told to draw in minimum mode, so we have to draw all the whole diagram of minimum mode. So there are 3 8282 8282, which gives us A0 to A19, then BHE bar, then we will be having 8286, 2 of them we will be having, and it will give us D0 to D15. Okay, bidirectional data bus, and we will be having a 3:8 decoder with 3 inputs: M/IO bar, read bar and write bar. This is nothing but 8086. So there will be a output called as memory read, memory write. Okay, so these two and many more outputs. So but we are concerned here with only 2 things, that is memory read and write. Now as we are having only one set of EEPROM, we'll make EEPROM. Now we will make here one set, but there are 2 banks, okay, of EEPROM, that is even bank and this is odd bank. So the total of it is 32 KB, but even bank 16 KB, odd bank 16 KB. Okay, so as it is 16 KB, so the address will be A0 to A14. Here also A0 to A14. Okay, and we have to draw OR gate, and the inputs will be, first as it is even bank, A0 will come to identify and Y0 bar. From the above decoder will come here as the input to this even bank A0 and Y0. Now as this is odd bank, it is identified by BHE bar, right? So we'll take this BHE bar and connect it here, and the next input will be Y0 bar. Now as this is even bank, the data line, this is even bank, so the data lines will be from D0 to D7, and here the data lines bidirectional will be D8 to D15. Now we want address lines, so here we are having A0 to A14, but now as we have reserved A0 for even bank identification, we will take the address lines from A1. Now as it is 15 bit, we'll take A1 to A15. Similarly here we will do the same, A1 to A15. So that's it, we are done with interfacing. No, one more thing is left, that is, as EEPROM is a read-only memory, so from decoder we will take memory read and we'll connect it to EEPROM. If instead of EEPROM it was SRAM, so we would have taken memory read as well as write as the input to both of the RAMs. Okay, so that was all about the interfacing.